Hello, this is Kirk Whittig. I will be going over conducting regression testing using Pspp and annotated bibliographies for 3 different readings throughout the course of this semester. This is being done for Dr. Nigel Bosta's GRC 605 Unit 6 presentation. The agenda is as follows: conducting a linear regression using Pspp on 3 separate tests. We'll first review 4-step considerations for running a linear regression test, then review 3 articles in an annotated bibliography format, and finally recap all of this. As for the hypothesis, we'd like to test the procedure for doing a regression test. That will follow these 4 steps: stating the hypothesis, formulating an analysis plan, analyzing the sample data, and interpreting the results. Remember that null will state that beta equals 0, and the alternative hypothesis states that beta is not 0, meaning there is more than one significant regressor. We also want to look at the rejection and the confirmation rules, where we reject when the null is P is less than alpha, where alpha is set at 0.05. And we also want to make sure that 0 is not within the 95% confidence interval. The first test, we found no significant regression, so a strength test is not needed here. The question was, can we predict a person's debt by knowing their income? With the dependent variable as debt, the independent variable as income. So again, no significant regression was found. Beta was negative 0.05, R squared 0.00, and P had a value of 0.535. On the second test, a significant regression was found. This test, the question asked, can we predict a person's savings by knowing their income, with the dependent variable being savings and the independent variable as income? The null hypothesis is that the regression coefficient, or beta, is 0, while the alternative is that beta is not 0. So with the results, we found that beta equals 0.91, R squared is 0.82, and P 0.00. So we accept the alternative hypothesis in this case. Also, the slope regression coefficient is positive and significantly different from 0, meaning there is a significant relationship between the independent and dependent variables of debt and income. Using the analysis plan, we know that the t-test shows a slope different from 0 also. R squared means that 82% of the model explains all variability of the response data around its mean. Finally, we look at the coefficient interval with the low side, or lower bound, as 0.09, and the upper bound, confidence in this, as 0.11. Does not contain 0, thereby lending support to the prediction. On the third test, we also found a significant result. The question was, can we predict a person's portfolio value by knowing their savings, where dependent variable was the stocks and the independent variable is the savings. Again, the results, we found a beta value of 0.28, R squared 0.07, and the P value is 0.000. The coefficient interval had a lower bound of 0.07, while the upper bound was 0.25. So again, this does not contain 0, thereby lending support to the prediction. Now let's jump into the annotated bibliography portion of this presentation. In this book's Chapter 2 on the correlation coefficient, Biddle straightforwardly breaks the process of running a correlation coefficient down into easily understandable words, steps, processes, charts, and informational graphics. In fact, Biddle likens the formula for the correlation coefficient to that of baking, where the recipe is the correlation coefficient and the ingredients are the data that must be incorporated in a step-by-step process to arrive at the proper outcome. Moreover, Biddle provides graphics for the written concepts that he is making, thereby fortifying the concepts, not only by using plain language, but also equally understandable charts and graphics. For the second annotated bibliography, I wanted to do a compilation of all of Dr. Hess's videos. I could not have completed my weekly assignments without any of his videos, all of which I listed below for references. There's one basic concept gleaned from every video: how to perform whatever given test we had in Pspp for that unit's assignment, plus instructions on how to import data into Pspp. Running and performing the weekly tests in Pspp were required for Units 4 through 6. After garnering the concepts from the other readings, we were then tasked with running a correlation analysis in Unit 4, onto running a chi-squared analysis in Unit 5, and finally a regression test in Unit 6. Every video equipped me with the nomenclature of Pspp, as well as provided wonderful step-by-step demonstrations and thorough explanations of the tests to run, as well as explaining the output data. Finally, for the third annotated bibliography, I'll look at the Psychology Research Method article by the University of Minnesota, which broke down and logically explained beyond a doubt what the role and purpose of a null hypothesis is and how to test it while incorporating sample size, p-value, and then discerning statistical versus practical significance. Plus, it explained the role of sampling error, thereby creating an effective and quick foundation for anyone wanting to brush up or learn for the first time what a null hypothesis in the research method provides, as well as how a sampling error, which refers to the random variability as represented by different R values, might do to your data. This paper easily dissected all the components of the null and explained how any statistical relationship can be interpreted in one of two ways. One, there is a relationship in the population, or two, there is no relationship, which again is the overarching logic of the null hypothesis. As for the conclusions and takeaway, linear regression tests are very easy to perform with Pspp using analyze, regression, and linear tabs to run the tests. There are many more values to distinguish with a linear regression test than the previous tests we have performed. Here are my references, and I'd like to thank you for watching, and please let me know if you have any further questions. Thank you.